A small glitch. Let me introduce our next keynote speaker. Dr. Jay Wing he's been graduated with a master's degree in microelectronics from the University of Technology, Malaysia. He has over 18 years of experience in the field in ASIC and FPGA development, which spans across front-end design, back-end structural design, verification, VLSI development, methodologies, and infrastructure development. In the 18 years, he has also led global development initiatives across the world, from various sites in US all the way to India. He holds one US patent and one patent pending. He is currently leading the development of PCI Express centric and high-speed serial interface solutions in the Intel Programming Solutions Group, PSG, delivering to data center and 5G areas. So let's welcome cordially Dr. Jay Wing to the next session. Thanks so much.
All right. Hello. Can you all see the screen sharing?
Yes, sir. We can see the share.
All right. Sounds good. Okay. Let me go ahead and make it the presentation. Give me a moment. All right. Let me get started. So good morning. It's an honor for me to be here today, and it's really great to have all of you here with me for this keynote to kick off the second day of the conference. All right, so I'm Jay Wing, and I'm the Director of Engineering at AMD Malaysia. So I've just switched from Intel to AMD around 2 or 3 months ago. Right, I would like to thank you, Dr. Padma, for inviting me to spend this day with you, and also to Dr. Avinash for connecting me to these prestigious events. To all the organizers, fellow technologists, and participants, welcome and thank you. So as I sat down to write this speech, right, as what every keynote speakers usually do, I tried to figure out what would be the most meaningful to everyone here. And after thinking over my holidays in Japan, right, it became clear to me that the keynote is best to be based on my life experience and not some theory that you can actually get from the books that you read. Right. So you wanted to know the best ways to make the decisions that you need to build your career of your dreams. Right. So this is what I'm going to share with you today. So the truth is that this current generation, with all the expansion of the internet, right, is actually much better positioned and much more prepared to navigate your career in this technologically fast-changing world. I remember that I was only exposed to the internet when I was 18 years old, but I have learned a few things that might be useful in your journey as well. So with the rest of my time, I would like to offer some suggestions of how you can shape your future. Right. So today, I would only want to tell you 3 realizations, right, from my life. No big deal, just 3 realizations. They are about handling change, what to focus on, and what to expect. So this is a small illustration of my work life. We would use it, you will see this again and again in the later sections of the keynote. So I started my career back at Intel, fresh out of college back in 2004 in the area of ASIC design. So I've worked on many different areas in the ASIC development flow, all the way from front end to the back end. And I was also fortunate to live in the US for 1 year, right? That's where you see there's a small star, Folsom in California, and also Chandler in Arizona, right? And I became a manager in the 7th year of my career. If you look at the logos that you can see in the fall, I've only changed my job twice in my career, right? And it's almost after a decade after I have been with that company, right? So I've changed from Intel to Altera, right, in 2012, and from Altera to AMD in 2022. So I've led global initiatives since 2007, right? After 3 years into my career, was fortunate to do that, right? And once I start to share the realizations, you will later see how each realizations that I'm sharing actually play a part in this same illustration. Right? The first realization is about change. So I've come to learn that change is the only constant in life. All things will pass and nothing will stay. If you compare this to the flow of a river, you will not be able to step into the same water twice in the river, right? Because once it's flow, it's gone. However, one constant since the beginning of time is that the fear of change. The fear of change is a constant. Both you and I like routines, right? As it makes us feel that we are in control of our lives. However, we are not spared from getting out of our comfort zone if we wanted to grow. Especially in the technology world, the pace of change is very fast. I remember that when I was small, I watched movie on the television in my living room, right? And that movie was at a predetermined time. You don't get to choose what you want to watch back then. But right now, right, with the technology advancement, both you and I can actually watch movies on our mobile devices wherever and whenever we want to. All right, so let's take a look about the changes in technology development. So this picture here shows the changes or the introduction of programming languages in software development. Right. So we always, if you look at it, we start off doing something that is really machine friendly, right? We started off doing binary codes where patterns of ones and zeros are being put on a piece of paper and then fed into some certain machine, right? That was the most primitive software. After that, it came on the assembly language, right? Where we learned the Motorola 68000, right? And this is where you learn opcodes such as the move and add opcodes. Next came high-level programming. This is the C programming as we know it. But however, it's still very low level, right? We still need to build our own data structures. And further evolution brought us database programming, right? That your database, such as the linked list, your FIFOs, right? Your arrays, right? Those are all pre-built in, right? You can query them simply. Right. We then progress on until what we have today, right? That we call it the multi-paradigm programming. This is where you can use different styles of programming across different platforms. And you can see throughout the years, software development has evolved through the time from being machine readable to human readable. Next, let's take a look at hardware development. Right. First, hardware development is very simple and it's very manual. Right. It was so simple that you can do a manual layout of the transistors that you wanted to draw. It then evolved into something that we call VLSI, very large scale integration. Right. This is where we are using synthesis of behavioral codes that we write into standard cells. Right. This was when also IP development starts to take a center stage. Right, where you see a lot of companies start to build commodity IPs. So high-speed IPs such as the PCI Express, the USB or Universal Serial Bus, Serial ATA, right? They were introduced back then, right? A lot of companies, and they are still here right now. Companies like Synopsys, right? They build and sell such IPs. After that, right, when it's nearing 2010s, suddenly there was a focus on SoC integration. Right? And why did this happen? This happened because there were a lot of companies who are providing IPs. So chip companies, they do not need to build their own IPs anymore, right? They can save themselves from the engineering costs from building or developing the IPs and directly assemble together a solution, right, by just purchasing the IPs and integrate them into a SoC. And right now, if you see, to continue Moore's law, right, we are moving into the area of chiplets integration. Right, so hardware development, as you can see, actually has gone through a similar manner, right, as what the software development is. Right, it changed from being manual to being very automated. Right, so as a summary, if you look at the pattern that has happened since then till now in the world of technology, you can see that the work will actually evolve to a higher level abstraction. And once it moves to a higher level abstraction, it means that it becomes more and more simple, right? I foresee that, you've given it another 5 to 10 years, RTL development will slowly disappear, right? Same as what will happen to the assembly language. Today, we don't write, or nobody writes assembly language anymore, right? RTL development will follow the same. And I do think that right now, all the human effort that is used to do SoC integration eventually it would be replaced and would be fully done by AI. So the big question comes is, if work is becoming simpler, how do you stand out? Right? Everything becomes so simple. It becomes human readable, right? So what is there left for us, and how we want to stand out in a company? So the answer to that question is, right, you need to understand the process and the flow, right? Because every tool runs on process and flows. So you need to become the person who understands the why and the how, and become the person who defines and develops the methodology and the tool. Don't just become the user. A user can only do limited things, right? But if you are the person who develop the methodology, understand the methodology and the tools, right, you can actually bend all the rules, right? You can make it better. So let's skip back and look at my work life. So in my career, there are actually moments that I find defining when I was really in control. I colored them up in the boxes in red, right? And those are the times when I work on the methodology, the flow, and the infrastructure, right? I see the problems, I define the solutions, right? And the thing that excites me is that you get to understand a lot of low-level details, and you get to do hands-on, right? You can actually imagine that, although my work as a director, I still go in and do write Perl scripts, right, just to help the team, right? And that is where it's important and you continue to learn the technical details as you still progress on in your career. And you can see that, after I understood that, right, throughout since 2009, I continue to work on methodology and infrastructure. I never gave up, right, working on methodology and infrastructure, right? And that was for the last 13 years, I still work on that. Okay, so this comes to the conclusion of the first realization. So key takeaway is that with all the changes that is happening, and all the automation that is happening, to make a difference, you need to understand the process and the flow, right? You need to do the hands-on, right? Don't be just a user. Be the person who can control what the process is and what the flow is. Next brings us to the second realization. I'm not sure whether you have heard about the power of law, but the power of law actually says that 80% of consequences comes from 20% of the causes, right? This is known to most people probably as the 80-20 rule or the Pareto principle. So based on this, you cannot and you will not be good at everything. So just focus on what will give you your best return, right? There's a saying that don't put all your eggs in one basket, but I think that should be changed to put your best eggs into one good basket. All right, so this is a graph that shows the power law distribution, right? It is trying to tell you that there are some certain activities that will give you the best results, right? A lot of other activities will not give you the best results, right? So you need to focus on these few areas here, right? And you need to be able to identify them. The first is we need to change our mindset. If you remember when you are young, you were told to learn everything, right? You need to go wide, you need to go deep, right? In Malaysia, we take a lot of additional subjects, right? For example, we just need to take 8 subjects for our government exam, but you see people taking all the way up to 12 or 13 subjects, right? And people join a lot of extracurricular activities, right? For example, you try to be good in sports, you try to be good, in a lot of other mathematic competitions or so on, right? But why is that? Because the education system and also how the environment is that if you do more, right, this will give you a better chance to go into university. However, this must change when you start to work, because you cannot be switching from every discipline, right? For example, you cannot say that you want to start your work in engineering, then halfway through you want to go to IT, and later you want to become a HR personnel. Because when you start to work, the experience that you gain on the job is what that matters, Second one is that don't diversify unnecessarily, right? People say that it's always good to learn as much as you can and as fast as you can, right? And because of that, some people also try to change role every year with the pretext of learning more. But what is the use of learning more without the ability of applying and making a positive contribution? So you need to spend the time to learn and spend the time to ensure that you can contribute something back before you move on, right? So there's no shortcut, there's no accelerated path, right? The last that relates to the power law is find and focus on something that you are good at. Everyone has their own weaknesses. You can spend time to reduce the weaknesses, but if you spend too much time over there, you will not have a very big return, right? Just do it adequately. Focus instead of using your strengths to your advantage, right? Going back to this diagram again, you can see that my entire career actually focuses on digital IC design, but I stepped through each and every area of it. Started off with verification, move on to do some back-end physical or structural design, right, before going back on to do front-end design, integration of all the different IPs, right, then work on methodology and infrastructure, then move on to do IP development, right? Then the rest of it is roughly similar, but in the area of FPGA, as Altera is working on FPGA instead of ASIC design, right? So I moved to different areas after I've made a positive change, right? So for each of these change that you see, right, I have already put in automation that makes things more efficient. I still remember clearly that in the area of physical design, this work actually needs the engineer or the responsible engineer to actually wait for the net list to be ready, right? And usually the net list comes out at the end of the week. They will always send it to you on the Friday evening, right? And then to save time, you are expected to work over the weekend. So what I did was that I prepared a couple of scripts, right? And I told the person who was supposed to deliver to me that, you know, after I write this script, you just need to run one extra command on your end, right? And what it will do is that it will go and kick off all the formal verification run. So for me, right, I do not need to stay there and wait for that anymore. I have my own Friday evening, I have my own weekend, right? I will only come back and check the results on Monday, right? So this is the efficiency that's added onto there, right? So you do not need to wait for anybody else. The person who completes their work, he can help you run one extra line of work, right? Then fast forwarding to the last few years, right? You can see that the commodity IP of PCI Express has been moved under my team's responsibilities, right? However, this is not easy. It actually took me 2 years for this to happen. The first half a year was to co-develop with my US counterparts or colleagues. Then the next half a year is where we start to develop it standalone, right? And finally, 1 year is for people to understand the results and the quality of the IP that we have done, right? Before the management decides that, hey, we can move this from the US to the Penang team, right? Going on to the last point, right? Be good at what you do, right? Pick something that you are good at. So I first realized that I find it easy to talk to people, to make connections, right? And being able to show empathy to people, you know, to balance between both people and project orientation, right? Thus, I decided to go on the management path. So this is actually reinforced when I hear comments from my close friends and from my team members. So I actually have friends, new friends that I've just met probably 1 week ago, right? They come and tell me that, you know, it's easy for them to open up and talk to me, right? Like they have known me for a while, right? And I also have team members, right, who came to me and tell me that, hey, I'm actually worried about your career when the project is in chaos, right? And they actually asked me if, you know, they could help with their extra time, right? So these are all the positive reinforcements, right, that I've gotten, right? So along the way, follow your heart, know that you know what you are good at, right? But sometimes you need the additional reinforcements or comments or feedback from people. And if you are doing a good job, you know, I'm sure that those will come. All right. So the key takeaway from the second realization, which is the power of law, is that focus your effort in an area that you are good at. All right. The third and final realization is that success is not a straight line, right? So nothing in life is easy, and you will surely encounter failures in your career, right? I have seen a lot of failures in my career as well. All right. So your life and my life is made up by a series of dots, right? Everything that you do means that you place a dot in your life, right? And there's no good mechanism, or there's no, I call it a litmus test, right, for where to place the correct dot. So one dot makes one point, right? But two dots makes a line. And once you have a lot of dots, right, you see that it makes a trend. So you need to continue putting the dots in the correct direction. So at every point of time, when you're feeling down and when you feel things are not correct, right, take a pause, reflect, right, and see the trend, right? If the trend is going down, that means that you need to do something different. All right. So you see, this is what people think success looks like. So everybody that is successful, like Bill Gates, maybe Elon Musk, right? Sundar Pichai, you think that their success is very simple. It's a one straight line. But if you really read through their stories, then you understand that their success, right, is probably something like on the right hand side, right? They probably scramble around, see failures before you see them as what they are today. All right. So the dots that you see just now maps into what my career growth is, right? So I started off my journey, my working life back in 2004, right? In Malaysia, there's something that they call a graduate trainee, right? So 6 months into the role, I was converted to a permanent employee. That's why you see there's a high in my career, right? Then after that, I see continuous high, right? I was promoted to the next grade. I was very happy with that. And then I was selected to go to the US or relocate to the US for 1 year to do a new IP development. Right? You can see all this while, right, it's a very good, nice trend. That was when you still see success is a straight line. After that, upon coming back from the US, right, the IP that I went to the US to develop, right, has actually very poor quality. So they have given me a few modules to develop. The modules should be very simple modules, right? They were expecting only 20 bugs or 20 defects, right? But the problem is, once they completed the project, the IP or the modules that I developed for the IP actually has more than 100 bugs, right? So that was when my focal or my evaluation for that year, right, was given a bad evaluation because of a poor quality of what I did on the design, right? Moving on, right, I was selected to manage a newly formed team, right? So another career high. Then after that, I was promoted. But however, after promotion, I did not my scope of work did not grow. I just maintained what I did previously. So to me, this one is actually a setback because at every point of time when you're promoted, you need to be able to learn and do something more, right? So that was when I decided, hey, it's time to change. So I switched company at that time to Altera and expanded my knowledge into FPGA, right? Then after that came another down point. What happened was that the IP that I was supposed to own upon joining Altera, right, that one was given to another site. So the team size that I should come into around 10 people, right, the team size that was reduced to only 3 people, right? But however, I continued on, right? Then after that came the next high point in my career where I managed to get a charter to work on global methodology and infrastructure, right? So the important part is the trend is important, right? You need to see that you have grown professionally, you have up-leveled your skills, your responsibilities, right? And of course, if you are working in a company, you want to see your grade level increase in the company as well, and that you have a continuous opportunity of continuing growing, right? That is what I call a good trend. All these dips, you have ups, you have downs, right? These are part and parcel of a career, right? So what you need to do is, at every point of time, just get back stronger. Know that you have learned something from your downs, right? And make it into something that you will not repeat again. All right. So let's take a peek back about how this plays out in my work life. Right. So you can see that from a skills and knowledge perspective, I covered different areas as I grow. Right. So regardless whether that I did a bad design for this one, right, but I think it's still fine because it's a learning, right? But I do see myself grow in terms of knowledge and skills, right? And I also told you that I became a manager 7 years into my career, which is roughly around here, right? You see that responsibility did grow as well, right? So to me, it's a good trend, right? Team size, right? You went, right? And these 80 people are actually global, right? In Malaysia, in India, and some in the US as well, right? So important part is that to follow the trend. There are points in your career that you fail, but I think that is fine, right? Anyway, for my story, I did not get laid off. I did not get kicked out, right? So I think that one is a good thing. All right. So the important part, right? The key takeaway in this third realization is that the uptrend is important. The dips are actually noise. So do ensure that when you look at trend, right, don't just look at one part of it. It needs to cover the full scale of all the knowledge, the skills. If you are a manager, then the influence is very important, right? And also the network that you have. Right. So as a summary, here are the 3 realizations that I wish you would take along in your career. Right. This marks the end of my keynote for today. Thank you all very much.
Any questions from audience? Any online participants or offline participants? Do you have any queries? Darshan, do you want to ask?
Hello, sir. It's so nice to meet you and listen to you. So I've listened to the power law that you spoke about. So you said that we have to put our efforts on the 20%. So there are so many things out there right now, especially in this age. So how do we know on which 20% we have to focus? Like how do we find out what are the things that we need to focus on?
I think that is a very good question. So one thing that you need to look at is what your strengths are today. What do you like to do and what you can produce good results with the least effort. Some people can do very good coding, right? So if you are good in coding, then you will need to look into the areas of what has the future growth in coding, right? For example, today, a lot of people are doing AI, a lot of people are doing machine learning, right? But once again, all these people, they are actually only the users of all those algorithms, right? If you ask me, I think that if you are good in coding and you want to pursue a good career with a good career path, right, be the one that is able to go and define new machine learning algorithms, right? So you do not want to do something that you are good at, but it does not have a growth trend. You need to look into something that you are good at and something that still have a growth trend. And I believe that if you look through the internet, read the company's report, you can see where every company is actually heading. And it's actually good for you to be in touch with some of the industry managers or tech people, right? If you have connection to them, right, it's good to have them tell you what they are focusing on, right? Because that will give you the future trend. Usually companies will start to work on things probably 3 or 4 years, right, before they comes out to the market.
Thank you, sir. Sir, there is one question in the online. Dr. D. Srinivas Rao has asked about does the parameters affect the VLSI design aspect?
Can I ask what parameters are those?
Srinivas sir, if you could respond in chat or through mic, we can get the question.
Sir, good morning, sir. Am I audible?
Yes, I can hear you.
Yes, sir. the main design parameters that affects the design of the VLSI to meet our objective in the design aspect.
Yeah, so there are multiple parameters that affect the VLSI design, right? So, and VLSI design, if you look at it in ASIC if you look at it from an ASIC standpoint versus an FPGA standpoint, it's very different, right? So, in ASIC design, the parameters that are important is actually the area, right? The flip-flop count. So the more flip-flop you use, the more expensive it is, and the bigger your your chip will be, right? So you need to reduce the flip-flop size that you have. But if you are doing a FPGA design, it's a totally different perspective, right? Because today in FPGA, the one that is more expensive is actually the logic gate counts or the lookup tables, right? And for those, you need to ensure that you use as minimum logic equations that you have for FPGA design, and you try to keep the logic size. If you're working in a company, you're building IPs on FPGA, you would want to ensure that you use the less logic gates as possible, because you want to allow your customers who use the FPGA to build their own logic into that, right? And if you are able to reduce the size of your IP, it actually helps you to improve your timing as well, right? Because once the FPGA gets congested, right, you will not be able to successfully close timing that easily, right? So as a comparison, in FPGA today, if you are a very good FPGA designer, you can close timing at around 500 megahertz. If you are doing VLSI design, right, it goes beyond 1 gigahertz already, right? So there is a lot of difference in the thoughts about how you want to, what kind of parameters affect the design, right? But the three traditional things that people always talk about, they call it the PPA, power, performance, and area, right? This one will always be there.
Okay, sir. Thank you. Thank you for your information.
Yeah, thank you.
So I'm here to thank you, sir. Your session on your talk is very interesting and inspiring, and especially you have quoted the change is a constant, and also like the other one, success is not a straight line. So these two are the inspiring quotations like you have quoted, and obviously I guess like students and the budding researchers will definitely be inspired with that. And your insights on the development of the technology, especially in VLSI and FPGA. So they have given good information. And I also thank behalf of the organization, organizing committee of the ICMACC, that your talk is inspiring and is very useful for the budding engineers in order to develop their career and choose. Thank you so much, sir.
Yeah, thank you so much.
Thank you, Wing. Wing is a director of Silicon and System Design Engineer at AMD. Sir is a very talented person and is committed, and deliverables also. He takes, he won't sleep when the task is on the toe. So really we are fortunate, sir, to attend your session. For all our students as well as participants and faculty members at our college. At present, we are having AMD campuses coming from Hyderabad for both UG and PG. I want to see some of our students working for under your guidance at AMU, AMD Malaysia. As for your needs, we will train our students. The bridge the gap between you and us is, I thank Avinash Adlapati for making this session happen. I thank Avinash and both of you for this session. And whenever you are visiting, next time we want to see you at our campus, sir. Not only your presence, and our students are also working for you under your guidance, even though at Malaysia or online, also at VNR. So definitely we need your support to grow further, sir. Thank you. Thank you for your wonderful time and talk, sir. Thank you, one and all.
All right. Thank you so much.